In today's episode, Sheedeh asks, will new advances like automated machine learning make data scientists obsolete? Most definitely not. Though I can understand why that would be a concern, because obviously automated machine learning makes many promises. Like it'll speed up your AI pipeline, it will make your company faster, data scientists are expensive, and so on and so forth. But a lot of the promises that are being marketed about AI, automated AI, are falling really short. AI is and should be automating a fair number of the tasks that data scientists do, but those tasks are they're low value. One hot encoding a table is a low value task from the perspective of if you're paying $300,000, $400,000, $500,000 a year for this person, having them encode a table is something that a machine should definitely do. It's not the best use of the time. And a lot of these newer automated frameworks make the promise that they'll handle everything for you. You just put in the data and magic happens. I've had a chance to test out a bunch of these frameworks, these automated machine learning frameworks. IBM's AutoAI, H2O's AutoML, Remix's AutoML. And the features that are in these toolkits are time savers for sure for data scientists, but they can't replace a data scientist. They can augment, they can reduce some of the repetitive tasks, the low value stuff, but they're not a replacement for the person. I'll give you an example. One of the key areas where automated machine learning really falls short and will for the foreseeable future is around feature engineering. Feature engineering is a fancy term in data science for essentially columns in a table, right? So if you have a spreadsheet, it's the columns in your spreadsheet. And there's 5 key types of feature engineering. Some machines can do well, some can't. As an example, let's imagine a table with 4 features, right? The date that you brewed a cup of coffee, the temperature of the coffee, what bean type you used, Colombian or Nicaraguan or whatever, and an outcome. Was it a good cup of coffee or not? And you want to know what makes for a good cup of coffee. Well, you've got a table with 4 features. It's not a whole lot of data to build a model on. Feature engineering is all about creating and updating and tuning your data so that you can build a better model. And that model can then be used to predict whether the next cup of coffee you're about to brew is going to be good or not, right? So we have date, temperature, bean varietal, and outcome. Was it a good cup or not? So the 5 areas of feature engineering. Number 1 is extraction. This is where machines really shine. Easy to do. If you have the date that you brewed a cup of coffee, what are the things in there? You have the day of the week. You have the day. You have the day of the month, the day of the year, the day of the quarter. You have the week of the year. You have the quarter. You have the month. You have the hour, the minute, the second, and so on and so forth. So you can expand that one field into a bunch of new fields. This is called feature extraction, and it is something that machines can do super well. So you could take that date and explode it. Maybe the hour of the day that you brew a cup of coffee matters. We don't know, but you could expand that. The second type of feature engineering is called feature estimation. And this is where it's called predictor importance or variable importance. Let's say that you expand that date field to all those possible variations, and then you run a machine learning model with the desired outcome being, it was a good cup of coffee. Does day of the week matter? When you run the model, the machine can spit back estimations of importance and say, no, day doesn't matter, but hour of the day does. So it can help you tune. So feature estimation helps you tune your table to avoid just adding crap to it all. All sorts of silly stuff. Again, something that machines can do very, very easily. Feature correction is the third area, and that is where you're trying to fix anomalies and errors. Machines can partly do that, right? So if there's a missing day, like you forgot to record a cup of coffee one day, a machine can identify that, like, hey, that's missing. But they're getting better at, but they're still not great at detecting things like bias, right? So, for example, bean varietal is one of the beans that is one of the features we're talking about in this fictional table. If you only buy Colombian coffee, guess what? You've got a bias in your data. The machine may not necessarily see that as an anomaly or as a bias. Like, hey, you've only bought one kind of coffee here this whole time, so the feature estimator may actually say this feature doesn't matter. Well, if you know anything about coffee, being varietal matters a whole lot, but if you've only tested one kind, you've got a bias in your data, and the machine won't know to detect that. In fact, it'll come up with the wrong answer and tell you to delete that column. The fourth area is feature creation. This is a creative task, being able to create net new features on a table. So say we have being varietal in there. A machine can look at the data set, and if you got Colombian and Nicaraguan and all this stuff, it can categorize that, but it can't add net new data. Like, an easy thing for us to do would be to add the price that we paid for that can of beans. Right? The machine doesn't know to ask for that. The machine doesn't even know how to get that, doesn't know that it exists. But we, as the humans, would need to create that feature. We need to bring in additional outside data that is not in the data set in order to create it. So feature creation, very difficult for machines to do. You need domain expertise to do that. And a follow-on fifth aspect of feature engineering is feature imputation, which is, as the expert, what's missing from the data set, right? So, for example, you brewed that cup of coffee, you got the temperature of the cup of coffee, great. I know, as someone who drinks coffee, that there is, depending on the cup it's served in, depending on the time of day, the ambient temperature, there is a lag time between the time it's brewed and the time you put it to your mouth and start drinking it. How long is that time? It's not in the data set, and you as a data scientist need to know, hey, if somebody let this cup of coffee sit on the counter for 10 minutes, it's going to be a very different temperature than if it comes right off of the machine. But that is, again, knowing what's missing from the data set. Cooling time is missing from the data set completely. And so as a domain expert in coffee, you would know this needs to be in there. And so automated machine learning can make the most of the data that you provide it, but it can't really do a great job of detecting bias. It can't bring in net new data for feature creation, and it can't do feature imputation. So a lot of these automated machine learning frameworks, if you hear companies saying this is magic, all you need to do is put in your data and the rest, leave it to the machines. Nope. It will speed up your data science. It will speed up your machine learning. It will speed up the outcomes that you get. It will make life easier for your data scientists, but it is not a replacement. And this is a good example in general of what AI can and cannot do. So, am I concerned that automated machine learning is going to make data scientists obsolete? No. My cup of coffee is a very simple example of just how off the rails that can go. Good question, important question. It's an important question to ask. And the answer is, you still need data scientists for the foreseeable future. As always, please leave your comments below, and please subscribe to the YouTube channel and the newsletter. I'll talk to you soon. Want help solving your company's data, analytics, and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.